Hi everyone, welcome back. A very good evening to you all. Myself Ayush Tripathi, DSM Internet Problem Setter at GeeksforGeeks, and welcome you all to this post analysis of last weekly contest 136. So can someone just please just confirm if I'm audible? Okay, let me check. So like before starting the discussion, I wanted you guys to rate the entire contest on a scale of 10. And in case if you are rating less than 4 or 5, then justify your reasons. It would help us to improve the upcoming problem set. And I personally categorize the contest from moderate to hard level. The fourth problem was based on a dynamic programming, just a bit optimization. 5 out of 10, 7, 10. All right, makes sense. So let's just quickly start the discussion. And I will be taking this session off camera to avoid any kind of glitches. Yes, the second question was very easy, and I guess it is easier than the first one. So let me just quickly share my screen. All right, so let me check if everything is good. All right, so everything seems good to me. So starting with the very first problem, Geek has an array of length n, and he want to divide the array into 4 parts, which follows these condition. 2 of 4 parts are of equal length, and same for the other 2 parts as well. And all the 4 parts must not be equal, must not have the equal length. And we need to report the number of ways in which the array can be partitioned and satisfying all the conditions. So how many of you were able to solve this problem? Any approaches? So the very first thing, if n is odd, then answer is never possible. So let me tell you why. So if n is odd, then answer can never be possible, because Geek divides this array into 4 parts, right? The length of first 2 parts will be same, and the length of other 2 parts will also be same. Those 4 parts are the length of the first part, x, then the length of the second part, it again must be x, then the length of the third part, let's say it is y not equal to x, and the length of the fourth part, again let's say y. So n minus length of the entire array minus the length of the first part plus the length of the second part. So minus 2x plus minus plus 2y, right? We are subtracting 2x minus plus 2y from this n, and we know no matter what is the parity of x and y, 2y and 2x will always be even. So this thing is even, and this one is also even, and the sum of two even numbers will always be even. And what we are doing, we are subtracting odd we are subtracting some even number from the odd number. So we are always left with some odd number, right? And so one element cannot be part of any partition. So if n is odd, then answer is 0. So is this observation is clear to everyone? Write a +1 if it is clear to you. Right? And now let's just break this thing into multiple cases. Now I know n is even, right? Now I know n is even. So let's just break it into multiple cases. The first case, in two cases, when n is divisible by 4, n mod 4 is equal to 0. And the second case, when n is not divisible by 4. So n mod 4 is not divisible by n mod 4 is not equal to 0. So then it will be equal to 2. And why I am saying 2? Because n is even, and if it is not divisible by 4, then we are only left with a remainder 2. Right? So let's just break this case first. So in this case, let's say the number of elements in the first part is x, or basically n by 4. Then the number of elements in the second part, again n by 4. Then the third part, again n by 4. And then in the fourth part, again n by 4. Right? So this is an invalid configuration. So because here it was mentioned that all the part must not be of equal length. So this is an invalid case. So let's just write other cases as well. And the sum of all the part must be equal to n. So let's say n by 4 minus 1, n by 4 minus 1, right? These two part are of same length, then n by 4 plus 1, right? And again n by 4 plus 1. I am subtracting 1 from these two part and adding 1 to these part. Then the next possible configuration can be n by 4 minus 2, n by 4 minus 2, subtracting 2 and adding 2 in these part. So basically now I'm trying to find how many possible divisions are there, how many number of ways to divide this. And see, currently I'm not considering the permutation. We'll consider the permutation little later on, but let's just only focus on this, how many unique partitions are possible. So n by 4 plus 2, then n by 4 plus 2, right? And so on. Then n by 4 minus 3, n by 4 minus 3, n by 4 plus 3, n by 4 plus 3, right? And how many times we can do this thing? We can do this thing exactly n by 4 times, right? So basically n by 4 divisions, 4 unique ways are possible. And out of these n by 4 unique ways, one way is invalid, this one, right? So our answer in this case would be n by 4 minus 1. These many unique partitions are there. And now we are interested to find the permutation for every partition. So we'll simply multiply it by 6. And why 6? For a given sequence, let's say for a given sequence, how many unique permutations are possible? So let's say we have a sequence A, A, B, B, then C, D. So how many unique permutation of this sequence is possible? So this is nothing but the length of sequence. So the length of this sequence is 6. So n factorial divided by frequency of A, which is 2, then frequency of B multiplied by the frequency of B, which is again 2 multiplied by the frequency of all the characters. So frequency of C is 1, frequency of D is also 1. That's why I'm not saying, right? In the same way, how many unique permutations of x x y y are possible? Because here the two partitions are of the same length and the other two partitions are of the same length. So the length of this sequence is 4 factorial divided by 2 factorial multiplied by 2 factorial, which is nothing but 4 into 3 into 2 divided by 2 into 2, which is equal to 6. So that's why I'm multiplying it with 6. So this is the first case. So is it clear to everyone? Write a +1 if it is clear to you. Write a +1 if it is clear to you. Right? Then the second case, when n mod 4 is equal to 2. So in this case, how many valid partitions are there? So again, we'll divide it into four parts. Let's say n by 4, n by 4, and n by 4, and n by 4. And this time I'm taking the floor value. So when I say n by 4, then this means floor value of n by 4. So don't get confused with this thing. So one partition could be n by 4, n by 4, then n by 4, and n by 4, right? And see, I will make this partition valid. And why I am saying that will make this partition valid? Because see, I am left with a remainder 2. So I will add this remainder either to this one, this one here, and one at here, or maybe one at here and one at here, right? So I will make this partition also valid. Then the next partition could be n by 4 minus 1, n by 4 minus 1, and again n by 4 plus 1, the same thing, n by 4 plus 1, right? And I will make all the partitions valid. So on, so far. We'll follow the same logic. So in this case, what will be answer? So in this case, our answer would be equal to n by 4, floor value of n by 4 multiplied by 6. Right? So is it clear to everyone? How many times we can partition it? N by 4 times the floor value of n by 4 and multiplying it by 6, because for every partition we can have a 6 permutation. 6 unique permutation for every sequence of length 4. Write a +1 if it is clear to you. Right? So this is the complete solution for this problem. Let me show you the implementation. So this function, and then first I'm checking if n mod 2, if n is odd or n is less than 4, then we'll simply return 0, because no partition is possible. Otherwise we'll divide n by 4, and then if n is multiple of 4, then we'll subtract k minus minus, right? So here k is equal to n by 4, and if n is divisible by 4, then k minus minus, and multiplying it with 6, and then simply returning this k. Right? So successfully submitted. Is there any doubt in this problem? So the second problem, which is dominating geek. So basically in this problem, you are given an array of size n, and in one operation, you can choose any number x and change all the occurrences of x to any other integer y in array A. And we need to report the minimum number of operation to make one element of this array A with frequency greater than n by 2. So this is a pretty standard and simple problem of a greedy algorithm. We always start with the integer whose frequency is maximum, right? So let me give you an example here. So let's say we have an array with elements 5, 5, 5, 5, and let's say then, or maybe start with let's start with 7. So 7, 7, 7, 7, and then 6, 6, then 4, 4, 3, 3, then 2, 1, and 0. So what is the length of this array? So the length of this array, 4 plus 2, 6, then 10 and 13. So n is equal to 13. So we want some element whose frequency is greater than n by 2, and n by 2 is equal to 12.5. So we want the element, the frequency of some element, let's say x, must be greater than or equal to 13, right? So not 13, but n by 2 here is 6.5, and greater than 6.5 is equal to lesser than greater than or equal to 7. So from which element we start? So the very first thing, first I will compress this using a map. So I will create a frequency array 4, 2, then 2, then again 2, 1, 1, and 1, right? So it's very obvious to see and very simple reasoning. We start with the element whose frequency is already maximum. So we'll start with this 4, right? And I will initialize my answer with 0. And we start with this 4 and we'll check whether it is greater than the current sum. So current sum is equal to frequency of the current element. So it is 4. Now I will check whether it is greater than n by 2 or not. And it is not greater than n by 2. So we need to perform an operation. So I will move to the next element, which is this 6. And yeah, we'll increment this answer by 1. So this means we have to perform the operation one time. Then in the next iteration, we have this 2. So I will add this 2, right? So we'll add this 2. Now again, I will check whether it is greater than n by 2 or not. N by 2 is equal to 7. N by 2 is equal to 6.5, and yeah, it is greater than or equal to 7 or not, and it is not equal to or greater than 7. So we perform the operation one more time. So we will increment the answer and move to the next element, which is 2, next frequency, which is 2, right? So again we'll add it. So now total sum is equal to 8, and this time it is greater than or equal to 7. So we'll break out this loop and we'll simply return this answer. And how we perform the operation, we'll simply change this one in one operation, this one to 7, and in the second operation, these one to 7. Now the frequency of 7 is greater than or equal to 7. So is it clear to everyone? This is the complete approach. We start with the element whose frequency is maximum, then the second element whose frequency is second maximum, and so on so far. Right, so I guess there is not much explanation required for this problem. So let me just quickly show you the implementation. So here we have a map, then updating the frequency of all the elements of A, then creating a frequency vector, and in this frequency vector I'm only storing the frequency of elements, unique element, right? Because we are only interested in frequency, not the values of the element. And then shorted this frequency array then initializing sum with 0 and answer with 0, then iterating from the larger frequency, that is from right to left, and adding the current frequency in sum, and if it is greater than n by 2, then we'll simply break it. Otherwise we increment the operation. We need to perform the operation one time, so we'll increment the answer, and finally we return this answer. Right, so successfully submitted. Then the third problem, this one, geeks like you. So how many of you were able to solve this problem? And this is the best problem of this contest. This one and the last problem, friendly neighborhood. So in this problem, the idea here is to use a monotonic stack. So expecting you guys, you are already familiar with a monotonic stack, as this is a problem solving session. So don't expect that I will teach the concept. Anyway, let's just go ahead. So Geek has an array A having n elements, and you need to determine the minimum length of a subarray starting from index I such that the sum of the subarray is strictly greater than 0. And you need to calculate the length for all I from 1 to n. Here 1 base indexing has been considered, so don't get confused with this thing. And if no such subarray exists, then return 0. So for this example, starting from I is equal to 0, so the minimum length of the subarray with the sum greater than 0 is this entire array. So 3. Then for index 1, the minimum length of the subarray starting from index I is 1 because the element itself is greater than 0. Then for the last index also, the element itself is greater than 0. So that's why the length is 1. So is it clear to everyone, the problem statement? So let's see how we can solve this problem. So now please try to pay more attention here. So let's say we have the prefix sum, and also let me draw an array. So index 0, so index 0, index 1, and let's say some index x and some index y, and then n minus 1, the last index. So the prefix of I denote the sum of elements from index 0 to I. So what we want for every x, what we want? For every x, we want prefix of x. What are the possible cases we can have? So the first possible case, when prefix of x is greater than prefix of y. So in this case, what does it mean? It means the sum of the element from x plus 1 to y is less than 0. Or let me just write it in more formal way. So we have a prefix of x. We know the prefix of x and prefix of y. Basically the sum from 0 to x and the sum from 0 to y. So what are the possible cases we can have? So the first case, what if prefix of x is greater than or equal to prefix of y. So what does it mean? It means the sum of elements from x plus 1 to y, from index x plus 1 to y is less than or equal to 0. x plus 1 to y is less than or equal to 0, right? And in the second case, if prefix of x is lesser than prefix of y, then what does it mean? Sum of elements from index x plus 1 to y is greater than 0, right? And for every x, we want to find the smallest y, as we need to report the length of the minimum length subarray with a sum greater than 0. So for every x, we want to find the smallest y for which the prefix of y is greater than prefix of x. So how we can find this thing? So in this problem, the idea here is to use a monotonic stack, and let me explain it to you. So we'll start from right to left, and we'll store the elements in increasing order. So let's say we have the index y1, then y2, then let's say y3, and maybe y4. And what if I got an element x, maybe let's say x dash, and for this index I want to find the answer, and assuming that prefix of x dash is greater than, so we'll store the elements in strictly increasing order. So let me write it here. So monotonic stack, so store the elements in strictly increasing order, and we'll tell you why I am storing the elements in strictly increasing order. So assuming that prefix of x dash is greater than prefix of y1, and also greater than or equal to prefix of y2. So in this case, my claim is that simply remove this one, because from x dash plus 1 to y1, the sum is less than or equal to 0, and also from x dash plus 1 to y2, the sum is less than or equal to 0. So yeah, so this cannot be my answer. So we'll simply remove it. So simply remove it. And in future as well, they are not useful, right? And now we got an index for which the prefix sum is greater than x dash. Now I know prefix of x dash is lesser than prefix of y3. So in this case, what will be my answer? My answer is simply equal to answer for x dash plus 1. Answer for x dash plus 1 is equal to y3 minus I, right? Y3 minus x. The answer, why I'm updating the answer for x dash plus 1. So let me explain it to you. So let's say I have index x dash here and then y3 here, right? So if this sum is greater than 0, then we'll update the answer. So this is the index from which the sum is greater than 0. So starting index is x plus 1. So that's why I'm updating the answer for index x dash plus 1. So this is the complete approach. Is it clear to everyone? Then we'll remove this y1 and y2, and we'll add the x1 here. We'll store the elements in strictly increasing order, right? And let's say we got an element x dash. So in this case, assuming that this x dash is smaller than prefix of x double dash is smaller than the prefix of greater than or equal to the prefix of x dash. So in that case, this is not helpless. This is not helpful, right? This x dash. And at the same time, you can also claim that this one and this one is also not useful. So that's why we have removed it, right? So yeah, you can try run for the given example by yourself, but this is the complete logic and the formula or yeah. So previously this x dash, let me explain it to you for the last time. This x dash, the value of this x dash is greater than y1 and y2, right? So that's why my claim is that simply remove it. Simply remove these two elements y1 and y2, and let's say we got next element x double dash, for which the value is greater than x dash. So we know if x dash value is greater than or equal to this x double dash value is greater than or equal to the value of x dash, then means this sum is negative from x double dash plus 1 to index x. The sum is negative x dash. The sum is negative or equal to 0, right? So this is useful. This is not useful for us, so we'll simply remove this x dash. And at the same time, the element that we have removed previously, y1 and y2, are also useless, because for them also the sum is negative or equal to 0. For them also here this sum is negative, or let me write it more formal way. So the sum from x dash plus 1 to index y1 is lesser than or equal to 0, then x dash plus 1 to y2 is also lesser than or equal to 0, right? And let's say I got this element x double dash, and the prefix of x double dash is greater than or equal to prefix of x dash. Then what does it mean? So this means the sum from x double dash plus 1 to x dash is lesser than or equal to 0, right? So if this sum is lesser than 0 in a negative number, in a, what we can say, yeah, non-positive number, you are adding some non-positive number, you are subtracting some non-positive number, then the answer would again be the non-positive number. So negative minus negative, the answer is negative. So that's the logic, right? So this is the complete logic. So write a plus one if it is clear to you. You can try run again some example by yourself, or let me check if some better example is given here. Or let's just leave it, and let me explain the last problem. So let me know if the logic is clear to you or not. And if it is not clear to you, then would recommend you guys to rewatch the recording of this session for this problem. But this is the complete approach from my side. Write a plus one if it is clear to you, or a minus one. How did n square solution pass to this? So maybe there is weak test cases, but in such case, if write to your solution in the comment, we'll definitely reply and check whether it passes all the test cases or not. But if it does, then the test cases are weak. Right? So let me show you the implementation here. But this is the complete logic. You can try run by yourself. It's just a wastage of time for me. So here we have a prefix array and finding the prefix vector and then updating this prefix vector, then using a stack here. Okay, let me explain the solution, then we'll try run for the second example. So then here I'm using a stack and finding the answer for index 0, right? Because for every x, we are updating the answer for x plus 1 and then iterating from right to left and storing the elements in increasing order. So if prefix of I is greater than or equal to the prefix of s dot top, and here I am storing the indices to find the answer efficiently. So instead of storing the values, store the indices, and this is one of the most common practice to solve such kind of problems. So takeaway from this problem can be this one, that we can also store the indices in the stack, and if the stack is empty, then it means we do not have any subarray starting from index I whose sum is greater than 0. So in that case, our answer will be equal to 0. Answer of I plus 1 is equal to 0. Otherwise, here I am checking if answer of, yeah, then otherwise I guess we can remove this thing. Otherwise, answer of I plus 1 is equal to st dot top, right? St dot top is the first y, smallest y, minus I, the number of elements starting from index I plus 1, and then we'll add this, push this I in this tag, and simply remove the result, because I am also storing the result for index n. Here you can see the result vector is of length n plus 1. So that's why removing the last result. All right, so successfully submitted. So let me just quickly dry run for the second example. So -2, -3, 5, -2, and 1. Right, so -3, -2, -3, 5, -2, and 1. Let me just quickly check. So we first find the prefix for every index, prefix array. So for index 0, the prefix sum is -2, then -2 plus -3, which is equal to -5, then 0, then here it is -2, and then -1, right? This is the prefix array. So then we'll iterate from right to left, and also let me draw the stack at the same time. So this time I will write the values and yeah, we'll write the values and indices both, but in the stack I will only store the indices, but just for an explanation purpose I will write values and index both. So we'll start from index n minus 1. So the first step is to remove the elements, right? The first step is to remove all the elements which are having value, prefix value lesser than or equal to this one, as we are interested to store the elements in strictly increasing order. So stack was empty. Then what would be the answer for this one? So if the stack is empty, so the first step is store elements in strictly increasing order. Then the second step is to find the answer, find answer. Then the third step is to push index I, right? So for the first one, the stack was empty. And also let me write the answer vector here. So index 0, so index 0, 1, 2, 3, 4, 5, yeah, 5, till 5 only. So we'll start from 4, this index, and 0, 1, 2, 3, and 4. So this time what we can see is stack is empty. So what I will do, I will update the answer for I plus 1 for index plus 1 with 0 if his stack is empty. So for this 5, the answer will be equal to 0. See, currently I'm not updating the answer for index 4. I am updating the answer for index I plus 1, or more formally you can say x plus 1, and then we'll push this in the stack. So which is 4 comma minus 1. And why 4 comma minus 1? Because the first one is a denoting the index, and the second one prefix value, prefix of I. So we have minus 1 here, we have minus 1, right? And then we'll move to the next index. So we are at this index. Now the first step is to store the element in strictly increasing order. So I will remove all the elements. So for this step, what I will do, I will remove while st prefix of st dot top. Let's say the name of the stack is st dot top is lesser than or equal to prefix of I. Then simply remove it. So st dot pop. So we had a minus 1, right? And we got minus 2. So an happy case is strictly increasing order. So we'll not remove anything. And then the next step is to find the answer. Yeah, the next step is to find the answer. And what is our answer? So answer is equal to answer of I plus 1. Answer of I plus 1, right? We are finding the answer for index I plus 1 is equal to st dot top minus st dot top minus 1, minus not 1 but minus I. So what is the value at st dot top? So st dot top is equal to 4, 4 minus 3, right? 4 minus 3. So answer of I plus 1, which is 4, is equal to answer of 4 is equal to 4 minus 3, which is equal to 1, right? So that is true as well. Answer of 4 is equal to 1. So from this index, the minimum length subarray with a sum greater than 0 is the current element itself, because its value is equal to 1 greater than 0. So an happy case, right? And then we'll push this. So 3 comma minus 2, and then we'll move to the next element. So what is the next element? So the next element, the prefix sum for the next element is 0. So we got 0, right? We got 0. So what I will do, I will store the elements in a strictly increasing order, the first step. So we'll remove all the indices for which the st.top, for which the prefix value is lesser than or equal to prefix of I. So we'll remove this 2. I will remove this 2 from the stack. We'll remove this 1 as well. We'll remove this 1 as well. And then currently we only have a yeah, we only have 0, right? So what is the value at yeah, so we only have one element which is 0. So currently the stack is empty because as I have removed -2 and -1. So what is the value of I plus 1? So the current value of I is 2. So we are at here. So what is the value? Value of I plus 1, which is 3. I plus 1, which is 3. So the value of 3 is equal to 0 because the stack is empty, right? And that makes sense as well. For this, starting the no subarray starting from this index having sum greater than 0. So for from this index we only have two subarray. One is itself, for which the sum is -2, and one is this one for which the sum is -1. So no subarray exists. So that's why answer of 3 is equal to 0, right? And then we'll push this in the stack. So 5, not 5, but index 2 and prefix sum 5, right? So it's not a 5 but 0. Prefix sum is 0. So 0, and then we'll move to the next element, which is index 1. So for here the prefix sum is -5. So an happy case, right? So -5. So the next step is to find the answer. So answer of I plus 1, I is equal to 1. So answer of 2 is equal to, what is st dot top? So st dot top is 2. 2 minus I. What is the value of I? I is 1. 2 minus I is 1, which is 1, right? And that makes sense as well. Starting from this subarray, is this index, starting from this index, the minimum length subarray is the element itself, right? Of length 1. It has value greater than 0. So we'll update the answer for 2 as 1. And then the next index, which is a 0. So what is the sum here? So it is -2, right? And also I will add this. So -3 and index 1 and prefix sum -5. This thing, right? Now what I got? I got -2. So I will remove this thing, right? I will remove this 5. So we'll remove this 5. We'll remove this -5, right? So I will remove this -5 from here, and then find the answer. Then we'll find the answer, right? And what is answer? So answer of 1, I plus 1. I is 0 and I plus 1, 0 plus 0 is equal to 1. st dot top. What we have at st dot top? So st dot top is equal to 2 and 2 minus 0, which is equal to 2, right? And that's making sense as well, I guess. Yeah, 2 minus 0 is equal to 2. So answer of 1 is equal to 2. So we'll update the answer of 1 is equal to 2. And yeah, that makes sense as well. From index 1, the minimum length subarray starting from index 1 with a sum greater than 0 is this one, -3 plus 5, which is equal to 2, greater than 0. So, and for index 0, we'll find separately. We'll find this answer separately for index 0 and then we'll remove this one answer for this last index. So this is the complete logic. Is it clear to everyone? Write a plus one if it is clear to you. Okay, Ankit is saying कुछ समझ नहीं आ रहा है. Okay, sure. So try to watch this intuition. I have already explained that the purpose of each and everything, why we are storing in monotonic, why we are using a monotonic stack and storing the element in strictly increasing order. So you can rewatch the recording of this session. So is it clear to everyone? Write a plus one if it is clear to you. So then the last problem, which is again an amazing problem. So in this problem, Peter and Miles, two superheroes, are on mission to defeat the monster, and each hero has their unique attack power. So Peter inflict damage per second, A damage per second, and Miles inflict B damage per second. So this A and B is given to you. There are n monster with a varying strength level represented by an array. Yeah, fourth one was easier than the third one. So there are n monster varying with a varying strength level represented by an array where the strength of the ith monster is denoted by strength of I, and Peter and Miles are determined to handle the monster individually. So on a single monster cannot fight against both Peter and Miles. So they will not fight against any monster together. And both of the superhero can attack any number of monsters in 1 second, and the damage can be divided in any way. It's up to us how we can divide the damage between the monster. And if Peter select one monster to fight, so Mile will never attack that monster. It's Peter task to defeat that monster between the monster during the second, and our goal is to find the minimum time needed to defeat all the monsters. So let's just see how we can solve this problem. So it's an pretty standard problem of a dynamic programming. So the idea here is to select the subset, right? Peter will select the subset, and that subset can be empty as well. And Peter will defeat that subset of monsters, right? And the rest of the monsters will fight against the mile. Now, if this thing is clear to you, so let's just write a recurrence relation here. So let's say f of I, comma x, comma y. So don't get confused with this thing. I'm explaining it one more time. The idea here is to use a brute force. Peter will select some subset of monster and fight against those monsters, and the rest of the monster will fight against Miles, right? Because it was mentioned here that if Peter select one monster, so then that monster will never fight with Miles in any second, and we can distribute the attack as per we want. So let's say the subset of the set of the monster is M. So Peter will select some set of the monster, let's say some subset of the monster, let's say M1. So then Peter will find, so this M1 is a subset of M, right? So with these monsters, Peter will fight, and the remaining monster M minus M1, M minus M1, with the remaining monsters, Mile will fight, right? And they cannot interpret each other. So now let's just define a recurrence relation here. So let's say f of I comma x comma y represents denote the time minimum time taken to defeat all monsters from index I to n minus 1. So then what are the transitions? And here what this x and y. So this x is the sum of the strength of the monster that Peter has selected. So sum of the strength of the monster that Peter has selected, and y represents the sum of the strength of the monster that Mile has selected. And Peter power is A. In 1 second, Peter can make a damage of A, while in 1 second, Mile can make a damage of B. Right? So what are the transitions? So for every index I, either for every ith monster, either Peter will fight or Mile will fight. So from here, I, comma x, comma y will make a two transitions, I plus 1 and x when ith monster will fight with Peter. So x plus strength of I, comma y will remain as it is. And in the second transition, when Mile decided to fight, so I plus 1, then x will remain as it is and y plus s of I, right? And since our goal is to minimize the time, so we'll take minimum of these two transitions, minimum of these two possibilities. And what will be my base case? So base case, so if I is equal to n, I am considering the zero based indexing, then we'll simply return ceil value of x by a. So ceil value of x is strength of the monster, sum of strength of the monster that fight against Peter. So ceil value of x by a, comma ceil value of y by b, right? So basically we'll take maximum out of these two things. And why maximum? Because this much time taken by Peter and this much time is taken by Mile. So we have to return the maximum time to defeat all the monsters. So maximum of these two things. This will be my base case. And now what is the time complexity? So the time complexity for this recursive solution is 2 power n. And why 2 power n? Because for every index we have two options. So it's kind of a binary tree, complete binary tree. For every node we have two child. So the time complexity for this recursive solution is exponential 2 power n, and this solution would definitely not pass. And let's just also analyze the constraint. So n can be up to 100 and strength of I can only be up to 1000. So n can be up to 100 only, and s of I can only be up to 1000, right? So what is the sum of strength? So summation of strength is not more than 10 power 5. So from 0 to n minus 1 s of I, this sum will always be lesser than or equal to 10 power 5, right? In the worst case, all the monster will have the maximum strength, which is 1000. So this is the time complexity for recursive solution. And what if we optimize it using a dynamic programming? So in that case, what is the solution? So how many different states are there? So the range for this I is in the range from 0 to 100, right? Where 100 is exclusive. So basically 100 possibilities. And the value of x can be from 0 to 10 power 5, and y can also be from 0 to 10 power 5, right? Now, if you even memorize it, then also the time complexity would be the number of different states, which is nothing but 100 multiplied by 10 power 5 multiplied by 10 power 5. So this solution is around time complexity 10 power 12, and this will also not pass in 1 second or maybe in 5 seconds also it will not pass. So this solution will also give you TLE, right? So what we can do, can we do something better? My answer is yes. And what something better that we can do? So my claim is that you don't need to memorize both x and y, only memorize one subset sum, and the other subset sum you can find easily by just subtracting the current subset sum from the total sum. So let's say, yeah, we only keep track of one subset sum. So let's say I know x. So let's say I have x. I have x. So how to find y? So y is nothing but simply total sum minus x. So the value of y is equal to summation from 0 to n minus 1 s of I, right? The sum of a strength of all the monsters minus x. And then the time complexity will reduce to 10 power 7, because this time we only need to memorize x and y. So let me write a complete transition here. So I, x, then the transitions are I plus 1, decided to add the monster in this subset. So x plus what? Plus s of I, right? And the next transitions when we do not add. So x plus I plus 1, comma, simply x will remain as it is, right? And this time also will take minimum out of these possibilities. And what will be my base case? So base case will be equal to, if I is equal to n, so in this case we'll simply return max of seal value of x by a, right? This subset of monster decided to fight against Peter, and the remaining monster will fight against Mile. So sum minus x, the sum of strength of the monster who fight against Mile. So then we'll take the seal value of it and we'll return maximum out of these two possibilities. So this is the complete solution. Is it clear to everyone? And now the number of different states are 100 multiplied by 10 power 5. This is the time complexity which we can pass in 1 second. Write a +1 if it is clear to you. And also please hit the like button. Yes, no, anything. Write a +1 if it is clear to you, or a -1. Okay, and +1 from Jashwant. What about other part, guys? No, the recursive solution takes a exponential time, because for every index we have two possibilities. We either add the value to x or y. So it's take exponential time. Right, so this was complete explanation from my side. Now let me just quickly show you the implementation. Here I am having a method to find the seal value of a by b. Then there's a dp vector. Then here in this we are also having a three attributes a, b, and a sum, where a is represents the attack power of Peter, then b for Mile, then updating this a and b, and sum, initializing sum with a 0, and this of a means attribute, and on the right side it means parameter. This a on the right side means parameter, right? So I am using this pointer which is pointing to the current object. So this of A means a attribute, and on the right side A means the parameter. So updating these attributes and initializing sum with 0, then sum, finding the sum of strength of all the monsters, then resizing this TP and calling the recursive function from 0 comma 0, where 0 is starting index, and the sum of the monsters that we have selected so far, sum of the strength of the monster that we have selected so far, and then passing this strength vector, then our base case. And if we have already computed this answer, then simply return it. Otherwise, we'll add this strength in current, or we can skip it. So then we'll take the minimum out of these two possibilities and finally return the answer. So the time complexity is 10 power 7 in the worst case, and the space complexity is also, right? So I guess we are good to wrap the session. Hope you guys have learned something new, and also share your feedback in the comment, as it would help me to improve the upcoming sessions. So yeah, thank you so much guys for joining the session. Have a good day. All right, thanks Vivek.